everyone to Growing the PHP Core one test at a time. With me, my name is Florian. I'm standing in the woods sometimes. I'm working at the profiler team at Datadog, where I'm building a continuous profiler for the PHP language. And besides that, I'm contributing to open source. That's mainly the PHP core itself, but also PHPUnit and GraphQLite. And I became the co-maintainer of the parallel extension, allowing you to do multi-threading in PHP. And I'm doing all of this, although I'm married with 5 kids. So that being said, even with 5 kids, you're gonna probably find some time to contribute to open source. Okay, here's a short story of how I got into PHP and how I got into software development. So in the year 1993, I got my first computer. That was an IBM PS2. It was a 286 machine, and alongside with that book, I got alongside with the computer, I got a book, a German print, but it roughly translates to GW Basic for bloody beginners. So I started writing code in BASIC. In 1995, I found out that the internet is a thing. And I went online for the first time, and I found out about all of these internet technologies, about HTML and JavaScript, about cascading style sheets, and also about Perl. That was the time when you just deployed stuff by sending files via FTP to your live machine, and then you hit F5 in the browser, and it was there or not. And September 2000, I joined an internet agency in Germany. They were basically just baking web pages. And they had 2 teams. They had a team doing Java server pages and another team doing PHP. I have no idea how I ended up in the PHP team, but somehow I got assigned to them. And that also, 2000 was also the year that PHP 4 got released. So most of the code that was there was still PHP 3 times. And I got assigned to the PHP team, so I sat with one of the engineers. And they showed me what PHP is about. I knew a bit about the internet. I knew HTML, JavaScript, CSS, a bit about Apache and these stuff. But I had never heard of PHP before. So they showed me that you can just open a file and add a echo 1+1. And then you go into the browser, hit F5, and you see a 2 there. They were excited. And they were like, oh, you see this, the computer, the server did the calculation. And then they showed me an include, that you could include another file. And it just showed up there magically. And while he showed me this, he asked me what I think about it, and I said, nobody will ever use this. So I started to explain what I meant by this, and the first thing was, I was like, well, we already have JavaScript, right? So this 1+1 example, I could just write document.write 1+1, and we would have the same effect in the browser. And even though these includes are pretty nice, but we could do the same thing on server side with Apache server-side includes. Just add an SSI tag, and Apache will do the include for you. And while I explained all of this, I noticed that it got silent in the room. So I turned around and looked in those faces. All the PHP developers. Good thing is they did not fire me on the spot. They explained to me what they were actually doing all day. They showed me some real source code they were working with, and they also showed me MySQL, some database stuff, what they were actually doing, like real-world projects. And in retrospective, that was also, for me, the moment that I realized what a software engineer is actually doing the entire day. I had no idea, but in that moment, I knew. So fast forward today. As I mentioned, I got introduced to PHP in 2000. That's 25 years from now. And my entire professional career is based on PHP. So let's say with a few exceptions, obviously, but I got paid to solve problems in PHP. Or better say, I got paid to solve problems, and I was able to do so 90% of the time by using PHP. So everything that I earned, everything that I've done, everything that I've achieved in my professional career is based on the fact that PHP existed back then, that still today people maintain PHP, and hopefully in the future people will also maintain PHP and write tests and contribute new features to the language. So I thought it would be time to give something back to the community. And while I looked at this, I found that there was a PHP Test Fest. The 2017 edition was the last edition so far. And that got organized by Ben Ramsey and Sammy Powers and a lot of other people that you might have heard the names from the PHP community already. And the idea was to write tests for PHP, which I thought to myself, that's pretty good, because that's usually how I approach a new code base. If I have no idea about the new code base, Usually I start to write some tests, execute the test, see the code coverage report, see what's not covered, add a new test, so that I make myself familiar with the code base. And I was thinking that maybe this is a good idea to do for PHP as well. Also, I had no idea that PHP had tests. And also, this means that I could start contributing to the language without creating an RFC, without writing C code, which I was not super familiar with back then. So that's what we're actually going to do today. We are going to build some PHP and write some tests. So if you want to build PHP, or if you want to write tests for PHP, first thing you need to do is you need to compile PHP from source. Basically, you just clone it. The PHP source code is in GitHub, so you can just clone. It's probably a good idea to fork before you clone, because you might not have push rights on the master branch. So basically, you clone the repository, you go into the directory, you run build-conf, configure, make, and after that, you have your PHP binary ready. And that's what we should see here. So I'm already in this directory where the PHP code is checked out. I've pre-compiled it already, as we can see, and in this SLI SAPI CLI PHP directory, CLI directory, there's a PHP binary. If you execute that, you can see this is PHP 8.50. That's from the master branch, and it has been built just this morning. So that's a fresh build. Okay, let's go back. The next thing you can do is you can compile run the tests. Run the test is pretty easy in PHP. You just run make test. Then it runs one test after the other. If you want to run tests in parallel, you can do so since PHP 7.4 by using this test PHP args-j, and that's exactly what we're going to do now. So in a second. This one, yeah. So you give this test PHP args-j10 or whatever, how many parallel workers you want to have, and then you can run the tests. This will spawn 10 test runners. We can see all the tests going through now. There is 10 of 10 concurrent test workers running that will execute those tests. We're going to see a lot of green paths in the first column. There will also be maybe some fail or warnings. There will also be some skips, definitely. And the next thing we're going to see is it's going fast. It's going through pretty fast, so we don't see it yet, but we'll see it when it's finished. We're going to see the name of the test that is being executed, and we'll also see the file that the test is in, so you can actually inspect that file if you see it failed. Then in the lower left corner, you can see the number of tests. There is overall 18,600 tests that are considered to be run for this test run. And we're currently at test number 7,000 something of 10 concurrent test workers. One thing we'll notice later is once the test is done, you'll get a summary of the test run. So you see what actually happened. You see all the failed tests, warnings, skip tests, like all of these things. And we also notice that once it's going to shut down, you're going to see that the number of concurrent test workers is going to be less and less until it finally finishes. So that's the point where I can drink something. Let's hope that there's not too many tests failing, because this will be released in a few days. There should not. For some of these tests that get skipped, we're going to see later, there is different reasons why tests can be skipped. The most likely reason here why a lot of tests are being skipped is actually that the extensions that they test are not in the build that I've done here. So there is a dependency in tests. Tests only run for extensions if they are there. Otherwise, they don't run because it makes no sense. They would fail anyway. So we should see in a second that the concurrent test workers are shutting down. Yes, so some of them are already finished. The last worker will keep on doing some more tests, because there are tests that cannot be run in parallel because they do have side effects, so they would be flaky in CI. So we don't do that. And the thing you notice is that it's bad at counting, because we are at 8,700 something of 8,600 tests. This is just all the tests that cannot run in parallel. They are executed in the end. And then at the end, we get this nice report here. So if we scroll a bit up, you can see this is what has been scrolling by, passed pretty fast. So we see the, if it passed, if it was skipped, we see the name of the test and the file name. And for the skipped, we also see the reason here why it was skipped. That's skipped because it's an online test and I'm not online now. Then we see the extensions that have been skipped. There is 30 extensions that do exist, but we didn't run the test for them just because they were not compiled in this binary. But 41 extensions have been tested. Then we see overall there's 21,000 tests, of which 17,000 have been executed. That's interesting. And it took 162 seconds to execute all of these tests. And then there is some failed tests. That's interesting. Somebody should better look for these. Then there is a warning test. You can see that this warning, this is an interesting warning because that test should fail because it has an X-fail. It has an X-fail section, but the test passed, which is also interesting. So let's say, what do we have? We have 99.9% of the test passed. That's good. Okay, so let's go back to the slides. So now that we executed the tests. So next thing is, how does a test actually look like? So all of the tests that we executed look like this. This is a PHP-T file. And basically, that's just PHP, or just ASCII text. And it's basically just divided into sections. So we have a test section that has a simple name. If you want to write more text, if you need more description about what you're testing and why you're doing it, there is a description block that you can add. That's not shown anywhere, but you can add it to the text, to the test without writing too much stuff in the test section. Then there is an extension section that allows you to list the extensions that you are depending on in your test so that it can be skipped if those extensions are not around. Then there is a more flexible skip if section that has been used in historical ways to find if the extension is installed. But if you have some more, I don't know, if you want to check if the internet connection is available or if you're on a specific operating system or a specific hardware, then you can do so in the skip if section if you know that this test only needs to run a specific hardware, for example. Then you set some PHP code in there, and this will skip the test if the output starts with skip. So the test runner will just execute this. Then you have a file section that is just the actual test that you're going to do. And because the output of the file section is matched against the content of the expect section, you usually see a lot of var dumps in those tests. Because you just var dump out whatever you have, and then you match against the expect section. And then last but not least, there is a clean section that is there to clean up after yourself. One of the things to notice here with the clean section, with all of this, is that all of those sections that contain PHP code will be executed by the test runner in isolation. So if you specify a variable in the file section, that variable does not exist anymore in the clean section, just to be aware of. So now that we know how a basic test looks like, the question is, what should we actually test? So in the old days, there was gcaf.php.net. Nowadays, all of this got moved to CodeCaf. So you can go to codecaf.io, find the repository and this link, and then you can see a lot of red for stuff that is not yet tested. So what I did back then, CodeCaf was not an option, but there was gcaf. I found this thing. This is a PHP function in the PHP source code. This is the setlibget coding type function. And it's all red. There's no test covering any of what's happening in there. So I was like, this is just like, by looking at it, even if you're not like familiar with C or with the PHP internals, basically that function is a switch statement on a variable, and then it's returning something. That's all it does. So I wanted to find out what this function is actually doing, and find also the bigger context in which this function is working. And the big context for this function is that PHP can do magic output compression for you. So if you enable output compression in the INI setting, and if a browser sends an HTTP request with an accept encoding header, then PHP will magically compress the output for that client, if it's enabled. And this function is just there for you in userland to find out if PHP will actually or is considering doing output compression, and if so, which compression algorithm it is using. If it's not doing any output compression, this returns false. That's all this function does. So in this case, we need to write a test that tests for the absence of an accept encoding header. If there is no accept encoding header in the HTTP request, this should return false. Otherwise, if we send gzip, it should return gzip, deflate. And if we send something else that's not considered supported by PHP, then it should also return false. So I prepared something. Let's go through a demo. And I have a demo set up, and that's gone. But here it is again. So let me zoom in a bit. So this test here is basically just testing what we just meant, the setlib get coding type function with the gzip encoding. We are depending on the setlib extension, so if that's not there, we don't want this test to run. And then we have our file section. The question that I stood in front was, this is reacting on the HTTP accept encoding. I don't have an HTTP request for this test, so how do I test this? Well, there is a $_server superglobal. All the HTTP headers that got sent with a request are populated into $_server, so I can just write into $_server, into the HTTP accept encoding key, the string gzip, and let's say fake an HTTP request that was sent with accept encoding gzip. Then we need to set the output compression to off, then call the setlib get coding type, just var dump out. That should give us a false because it's turned off, although the client accepts it. And then if we turn the output compression to on again, and then call setlib get coding type, now the situation is that the client indicated that they understand gzip encoding, while setlib get coding type is enabled, so setlib get coding type should return a string of gzip. So that's basically the entire test I built, and I was like, this should do it, so let's run this test. And if you want to run a single test, you can just run make test and give it the tests argument and then the path to the file that it should test. Hit enter and see it run. And okay, so what we see is it ran the test. The foo1.phpt, we see in the diff output that something failed and the test itself failed. So the good news here, it failed in just 47 milliseconds. That's good. But the question is, why did it fail? So the test runner that executes the tests creates a lot of files. And if the test fails, then it leaves you with all of them. So we can have a look into the log. And in the log, again, we see like the other one was the diff output. You can also get a diff, you can get the log. There's different output formats. So in this case, we can see that we expected a Boolean false, and we can see in the actual output that's there. So the first var dump succeeded. But after that, we get this warning, INI set cannot change setlib output compression, headers already sent. And I was like, that's weird, because I don't remember setting any headers. And that's this line, this var dump here, where the test runner complains, or where in the output it complains that we are unable to change the INI setting because the headers have been sent here. So what's happening is PHP will send response header to the client. And the problem with that is once those response headers have been sent, PHP is communicating to the client, to the HTTP client, if we actually use some kind of compression. Like the HTTP client might suggest use HTTP accept encoding gzip, and we might send a gzip compressed output stream, but we might also not. This is up to us to decide, up to the server side. So the problem is when we start sending output, PHP will magically already create all the response headers and will start sending them to the client. And that means that we cannot change the output compression anymore because we already told the client that we are not using any output compression. So there's an easy fix for this. We just don't do any output. So let's just save this in a variable. And output it here. And now we are setting the INI setting. We have gzip encoding set. We do the clib and setlib encoding. We store it in a variable so we don't do any output. Then we set it back again. And then we run this, and hopefully this time it works. So let's execute the test again. And it failed again. I would say this is progress because the error message changed. One what we have now is, you can look into the log file. The error message is gone, that is pretty good, but the first Boolean false is still there, but for the second thing, there is a string for gzip expected, but we get a Boolean false. Which is weird, because just looking at the test, it's like we have output compression turned on, HTTP accept encoding is set to gzip, so that second call should actually give us gzip, but it doesn't. So I was looking at this and I was like, this is weird because I think I've done everything correct. Maybe there is something with, possibly it's not that easy to inject an HTTP request. I was not sure, so I wanted to go and check out the source code of this function. So let's go here and find the function. Here it is. This is basically the function that we had in the screenshot. That's the PHP function setlib decoding type, so what you can call. It's the switch statement on this variable, and I was thinking like, well, somewhere someone has to write to this compression coding variable. Otherwise, we won't be able to switch on it. So just searching through it, there is this reading, there's also reading from the data, there's also reading, and this is interesting because these two places is where actually it gets written in this PHP setlib output encoding function. And this is the two places where PHP setlib encoding gzip or deflate will be written to that variable. So this is what we need to influence. And then I saw this if condition here, which is pretty weird. Even with not understanding a lot of C internals or PHP internals, it looks a bit like this is checking if this is the $_server variable, if that exists, or if it's this auto global thing exists. And this looks like this is send hash string find. It's good to know that PHP arrays are basically hash maps. So this is searching in a hash map for something that is called HTTP accept encoding. And this is the track var server. So this is actually looks like this is reading from the $_server HTTP accept encoding, which we just changed. So it should magically just work. But for some reason it didn't. And actually looking at this code, this bakes my case. This bakes that I've done everything correct. Turns out that there is something more to PHP internals or to PHP autoglobals. I got stuck there and I reached out to PHP people on the phpc.chat. That's a Discord nowadays, so you can go there and ask the people, what are you trying to do? And that, like, you check the source code and actually, like, you might not even understand everything, but it looks like it bakes your case. And they were like, yeah, this is totally fine, this is true. The problem is that superglobals, user-generated superglobals, no, user-accessible superglobals in PHP are copy on write. So going back to our test, the $_server superglobal exists at the moment PHP gets booted. But the problem is what we do here is we set the HTTP accept encoding to gzip, which might not have existed. The thing is we change the $_server variable, and what PHP is doing now is PHP creates a copy for us in userland to work with. So from this moment forward, the $_server that PHP internally uses diverges from the $_server variable that we have in userland. Which makes total sense. Because the HTTP request is immutable and we should not just change and fiddle with it. So I was like, okay, well, I need another way to inject this HTTP accept encoding variable then. And by looking at the documentation of the PHP files, I found that there is way more sections. And one of the sections is an env section, which we'll add. And the env section is basically just setting environment variables that will be injected into the PHP process when it starts. And luckily, the environment variables will also be populated to the $_server autoglobal. So this is another way to fake it in somehow. And it should be there from the beginning. We are not changing it in our source code anymore. So now the test should actually work. So let's execute it and see what we get. And it fails again. But this time we fucked it up. This is just some binary garbage that we get. Anyone has an idea what this is? Yeah, gzip, I heard it. This is gzip. Obviously, because that's what we do, we fake an HTTP request that says the client is accepting gzip, and in the end, the output compression is turned on, so PHP will do output compression for us. So let's change this a bit and cache all of that stuff. Turn it back off. And now we should actually be in a situation where it succeeds. Let's run it again and see. Ah, finally. Okay. So I do have this is the final example as you can find it in the PHP source code repository. That's what I committed. And after I committed this for PHP 7.3, it got released in PHP 7.3. There was a new run for gcarf, and now finally there is some coverage on all of these lines. There is no coverage for this return, but that's okay because that is just because this is just asserting that you do not call the setlib coding type function with any arguments because it doesn't expect any. So usually there are no tests for these cases because we don't need them. That's okay. So on all of this stuff that I did, all of the work, all of the way, I learned a lot of stuff about PHP that I didn't know before. The obvious thing is we are not doing this because it's easy, but we're doing it because we thought it would be easy. It looked super easy, just a switch statement on a variable returning 2 different cases or 3 different cases. Turned out it's a bit more in there. I learned that superglobals are copy and write. I knew that PHP is using copy and write in a lot of places, but I wasn't aware that this is also true for the $_server, $get, post, whatever superglobals we have. But it totally makes sense to have them copy and write because it makes the HTTP request immutable to the user space. And also that there is modifier handlers for any settings. I wasn't aware of that. I actually believe that, well, anyset and anyget is just setting the INI setting to something, and after that PHP is behaving. But that's not true, because as we've seen in the test, it makes no sense to change this INI setting anymore once we have sent the header, because there is no way for PHP to signal to the client that we changed this. So this would just mess up a lot of stuff. And there is something in for you if you start writing tests for PHP. If you're interested in doing this, first of all, PHP will be more stable and reliable. That's just a good thing, I would say. There is a lot of tests to be written out there. So the next version, something will not fail if you add a test for it, or it will at least not fail silently and nobody notices. The other thing is I gained, you might also gain a more deeper understanding of how PHP works internally. For me, one of the things that I found that was pretty interesting when I rambled through the code coverage report and found stuff that is not yet covered, I found that there is a zip archive class, which I wasn't aware exists before. Let's say in the old day, in up to 2010 or so, whenever there was some customer request of, oh, we're going to upload this zip file and there is some images or CSVs or whatever in there, you were like, oh no, I have to use system and then call the zip binary and do stuff, and that's super horrible. The zip archive class is pretty amazing, actually. It gives you an object-oriented interface to zip files. And I had no idea that this thing existed just by finding in the code coverage report that there are tests missing for it. So I wrote some tests and found out that this is a thing. And also, the PHP file format that we just learned about is not tied only to the PHP core itself, but PHP unit also has a runner that executes those PHP files for you. So if you create let's say a CLI application or a SAPI, this might be super helpful for you to write tests in PHP file format. And let's say the best thing that you get for writing tests for PHP is that you can tell anyone, if they want to hear it or not, that you are a PHP contributor. And with that being said, thank you very much.